Okay, we're still in section 5.4. This time we're going to be working in reverse. Now we're going to have a graph with some information, and we need to find out the equation for the appropriate trig function. So first of all, we want to pick the correct trig function based on what we see from the graph. So right now we're just going to have two choices since we're in the tangent-cotangent section. So if we have an increasing graph, so it's increasing from left to right, we know that that's going to be our tangent equation. If it's decreasing from left to right, okay, so if it's decreasing, my little C's in there, decreasing means we're going to be looking at the cotangent equation. Okay, then we're going to find our period, and then we're going to use that information to find B. Well, to find the period is the absolute value of the difference, or the distance, between the two asymptotes. And to find the distance, you need to subtract. That's why I'm saying difference. So the absolute value of the difference between, for some reason I'm having a hard time spelling today, between the asymptotes. Okay, so then once we do that, then we can use our formula of P is equal to pi over B. Now you'll see that I dropped the absolute value around the B, and that's because when we find P, we're taking the absolute value there, so we're just trying to find out what our B value is. Okay, number 3, then use the given points, given point or points, and probably just going to be given one, but that point cannot be the t-intercept, which is the x-intercept, and we'll use that to find A, and then we write our final equation. Okay, so let's take a look at our first example. It says, find an equation to fit the graph. Our window is from negative pi over 2 to pi. Okay, so let's just go ahead and let's label that. So that means our value over here is negative pi over 2, and this goes to pi. Now if we break that down, we know that this is 0. And what's halfway between 0 and pi? Well, that's pi over 2. Well, that gives us our x-intercepts, but what we really need to know are where our asymptotes are. So we can kind of sketch those in. Okay, so that's some information that we have. Let's also look at the scale on our y. That goes, it says from negative 2 to 2, so here's negative 2, and here's positive 2. And then they give us a point, so this is our x and our y, or if you're using t and y, it would be, obviously, t would be pi over 8, and y would be 1/2. Okay, so the first thing we're going to do is we're going to look at what's happening with our graph. So first of all, we see it's increasing. So increasing function is going to give us a tangent function, so we know that y is equal to a times the tangent of bt, or bx, whichever one you want to use. Step number 2. We need to find the period. So P is equal to the absolute value of the distance between two of the asymptotes. Well, let's take a look at just what we have here, this period. We'll try to figure this one out. Well, we know this is 0, and we know that this is negative pi over 2, so halfway in between, that's negative pi over 4. Same thing over here, this is 0, this is positive pi over 2, so our asymptote is at positive pi over 4. So we're going to subtract these two, so we're going to have pi over 4 minus a negative pi over 4, which will then give us 2 pi over 4. We can drop the absolute value since it's positive, which reduces to pi over 2. So our period is pi over 2, so we need to use that to then find B. So our formula is P is equal to pi over B. So we have pi over 2 is equal to pi over b. Now this is set up so we can cross multiply like a proportion, and we would end up with b pi is equal to 2 pi. Divide both sides by pi and we get b equal to 2. Okay, step number 3. We're going to plug in everything that we know, and then we're going to solve this for a. So we know our y-coordinate is 1/2. That's going to equal a, which is what we're trying to find, times the tangent of our b value, which we just found b to be 2. So 2 times pi over 8. Okay, if we simplify this, we get 1/2 is equal to a times the tangent of pi over 4. And if we solve that for a, let's put that up over here, we get a is equal to 1/2 divided by the tangent of pi over 4. Well, what's the tangent of pi over 4 equal to? Well, that's 1. So that's 1/2 over 1, so we know a is equal to 1/2. Last step, let's write our finished equation. So we're going to have y is equal to 1/2 times the tangent of 2t. Okay, second example, find the equation to fit this graph. This time we're being told that our window is from -2 to 4. So let's label that, -2 to -4. Our y is from -5 to 5. And then the information about our point is listed here at the bottom. So our x is 0.5 and our y is 0.3. So our graph, we start off, this one's decreasing. So we have y is equal to a times the cotangent of bt. Step number 2, our period. So let's look and see where our asymptotes are. So we have an asymptote at 0, and we have an asymptote at 2. So we know p is equal to the absolute value of 2 minus 0, which is equal to 2. Use that information to solve for b. So we have 2 is equal to pi over b, and if we solve that for b, b is equal to pi over 2. Okay, now we can plug everything in and figure out what a is. So we have 3 is equal to a times the cotangent of pi over 2 times 0.5, which is 1/2. So we have 3 is equal to a times the cotangent of pi over 4. So a is equal to 3 divided by the cotangent of pi over 4. The cotangent of pi over 4 is 1. So that's 3 divided by 1 is 3, so our a value is 3. And our last step, we write our equation. Move this down just a little bit. So we're going to have y is equal to 3 times the cotangent of pi over 2t. Okay, there we are.